Welcome, I'm Chung. This audio slides gives a brief introduction on the topic, Magnetoelectronic and optical properties of non-uniform graphene nanoribbons. The article's DOI is shown at the bottom left corner. The geometric configuration of non-uniform bilayer graphene nanoribbon is a strip-like structure with a narrow top layer and a wide bottom layer. The magnetoelectronic and optical properties are directly dependent on the geometric configurations, such as the widths of the top and bottom layers, the relative distance between their edges, and the inner boundaries of the top nanoribbon. We will introduce the magnetoelectronic and optical properties of monolayer and bilayer graphene nanoribbons before go to the motivation. As shown in the table, the magnetoelectronic and optical properties of monolayer and bilayer graphene nanoribbons are much different, such as geometric structure, band structure, density of states, wave function, and absorption spectrum. Because the non-uniform bilayer graphene nanoribbon is an intermediate system between monolayer and bilayer graphene nanoribbons, it's a suitable system for studying, first, how the narrow top ribbon affects the physical properties of the wide bottom ribbon. Second, how the physical properties transform from the monolayer to bilayer ones. Third, coexistence of monolayer and bilayer properties. And last, it also provides an example system for understanding other similar structures and the effect of van der Waals interactions. The tie-binding model with spiral substitution is used in this study. The diagonalization of the Hamiltonian matrix yields the band structure and the wave functions. Then the density states can be obtained. Also, the optical absorption spectrum is given by Fermi's golden rule. The magnetoelectronic and optical properties are directly dependent on the geometric configuration and the strength of magnetic fields. For simplicity, the strength of magnetic field is kept fixed. The gray zones indicate the top view of each geometric configuration of non-uniform bilayer graphene nanoribbon. The dark and light zones indicate the top and bottom layers respectively. In order to understand the effect of narrow top ribbon, the top ribbon is put on three different places: left edge, center, and right edge of the wide bottom ribbon. The physical properties, including band structures, density of states, wave functions, and absorption spectra, are discussed. To understand how the physical property transforms from the monolayer to bilayer ones, several specific top ribbon widths are discussed. To understand the coexistence of monolayer and bilayer properties, the overlapping and non-overlapping regions of different widths and places are discussed. The low-energy magnetoelectronic and optical properties of non-uniform bilayer graphene nanoribbons can be considerably altered by changing their geometric configuration. There are four categories of quasi-Landau-level spectra and the corresponding absorption spectra. That is to say, monolayer-like, bilayer-like, coexistent, and irregular oscillatory spectra. Moreover, the study provides an essential understanding about the magnetoelectronic and optical properties of other similar structures and the effect of van der Waals interactions, such as partially overlapping graphene nanoribbons, graphene nanoribbon graphene superlattices, and the van der Waals heterostructures. I'm Chung. Thanks for your attention.